Alright, so some more of these problems. Exercise 2D, questions 7 to 9. They're starting to get a little bit harder, but hopefully you've practiced the first 6, so you'll be on the right track. Alright, so another sort of problem, a cuboid with square base is to be made with 200 centimeters squared of material. I'll draw a diagram for this one. So the thing is basically a square-based pyramid, sorry, square-based prism. Yeah, that's my diagram. I'm going to let X be the base, the length of the base. Okay, since we've got squares on the top and bottom, both of these are X, and I'll call H the height. Okay, I read this question. I'm trying to find the maximum volume. Okay, again, I'm going to pretty much ignore the first two parts of the question, but I'll probably get there anyway, just as I solve the problem normally. Let V be the volume. Now I'll write my formula for volume. Again, volume is area of base times the height. In this case, the area of my base area of the square, so area of a square with side length x is x squared h. So E equals x squared h. Alright, let's see if I can find some relationship between x and h so I can eliminate one of the variables. Well, it's got the relationship there for me. Hopefully I can make that on my own though. Alright, so it's got something to do with this figure here, with the amount of material. It's really telling me that the surface area is 200 centimeters squared. Alright. For some reason year 12 is always horrible at surface area. I need to draw a net of the prism, and I need to find how much of this is find the surface area of this thing, which I can cut out and make this 3D shape. Okay, this is what the 3D shape looks like. And what we can see is these two shapes are the same, so I'll call them both shape 1, and then all of these 4 shapes are also the same, so there's shape 2. Okay, so if I'm calculating the surface area, I've got 2 lots of whatever shape 1 is, plus 4 lots of whatever shape 2 is. Alright, so the area of shape 1 is just the area of the base, which is x squared, but I've got 2 lots of them. The area of, so this is x and x. The area of shape 2, we could put the dimensions all over this thing if we wanted to, if you're struggling with it. The area of shape 2 will be h times x, or xh. Okay, probably hx. Put it the other way around. hx, and I've got 4 lots of them. So that's my surface area. Okay, and I also know that the surface area is 200. Okay, so there's my relationship between x and h, which I'm going to somehow rearrange and put in here. Again, I look at these 2 things that I can possibly substitute in. I'm going to choose h, okay, because the thing I have to substitute in there, I won't have to square. And if I'm trying to rearrange for x here, it's going to be pretty hard. Alright, so I'll bring 2x squared over, okay, 4hx, and then rearrange this for h. So h equals 200 minus 2x squared all over 4h. I'll probably leave it like this to substitute in. And just because I know I can't divide the 4's all the way in here, it should be over 4x. Oops, then dividing by 4x to get h by itself. If I wanted to make it look like this answer up here, okay, I could do that just by dividing both of these terms on the top line by 4x. Okay, we'll get there. 200 divided by 4 is 50. Yeah, it's just cancelling. And look on here, I'll put a fraction line down. X squared on x is x, 2 on 4 is a half. Okay, there's the answer for part A, if you really were curious on how to do that. Okay, but anyway, I'm going to here substitute h equals 200 minus 2x squared on 4x into v equals x squared h. So v equals x squared. Better be consistent with my different color usage. 200 minus 2x squared all over 4x. And again, I'll probably try and make this a little bit simpler doing the multiplication. Remember, imagine it's divided by 1. V equals x squared, 200 minus 2x squared over 1 times 4x. Okay, which then I can then write as, so cancelling the x squared with an x on the bottom, just x 200 minus 2x squared all over 4. Can do the expansion on the top line, 200x minus 2x cubed all over 4. And if you want, you can then separate these two. So 200x divided by 4 is 50x. 2x cubed divided by 4 will just be a half x cubed. Okay, this 2 and this 4 is really just 1/2. Okay, and then you should be able to differentiate and solve from here. Okay, question 8. The window frame is in the shape of a semicircle joined to a rectangle. Find the maximum area of a window using 300 centimeters of framework. Alright, so I'll draw just a basic diagram here that I can play with. We could go around this, so 300 centimeters of framework, that's referring to the perimeter. Okay, I could go around this whole diagram and say this is L, this is W, this is R. I'm going to try and minimize the number of variables that I use. So I know I'm going to have to do something with the circle, so I'm going to just call this R for now. Okay, so let radius, let R be the radius. Okay, I also know that this thing has some height. Okay, so let H be the height. And whatever I want to call this, I'm just going to notice that this is 2R. Okay, see how it's twice the radius. And that'll just give me 2 variables and hopefully simplify everything when I start writing down relationships. And reading the question, what am I trying to maximise? Trying to maximise the area. I need to find a formula for the area. Okay, area of this thing is area of a rectangle plus the area of a semicircle. The area of this rectangle is 2RH, just multiplying these two together, plus the area of a semicircle. The area of a circle is pi r squared. I need to divide that by 2 to make it into an area of a semicircle. Okay, so again, I've got r's and h's all over the place. I know that the total amount of framework, the perimeter, is 300, so I can write some relationship for perimeter. Okay, I'm just going to work our way around this shape. So I'm going to start here and go clockwise. So I've got H, and then I go 2R, and then I go H again, and then I go half of a circle. Circumference of the circle is 2 pi r. I can divide that through by 2. Okay, so I'll have to do some cleaning up here. Okay, before I can substitute anything in, I'll look here, where do I want to substitute? So, do I want to get H or R by itself? Well, I'll just clean it up a little bit to have a better look at it. So I've got 2H plus 2R plus pi r. I'm going to try and get H by itself. Okay, because 2 reasons. They only exist once in the formula, and also it's not squared. Okay, so the goal is to get H by itself. So 300, I'll subtract these two things, so minus 2R minus pi r is H, and then I can, is 2H, sorry, and then I can divide everything by 2. Okay, divide it all by 2, and I'll be substituting this expression into here. So it might get a little bit messy, but I think this 2 here is going to help out to cancel out the 2 underneath. Okay, but I'll leave those to you now. I'm spending too much time doing these problems. Okay, you should be okay from there. Alright, rectangular sheet, 50 centimeters by 40 centimeters is to have square corners cut out so they can be folded into a rectangular tray. So this is going to turn into a rectangular tray, like a three-dimensional tray. Alright, I'm sure you've done this example last year. Okay, I'm going to let X be the dimensions of the length of the square. Okay, that is cut out. Okay, so all of these little dimensions are X, because that's the thing that we can really vary. Alright, and I'm just going to let V be the volume of the tray. Happy birthday, Marco. I draw my tray in 3D. The dimensions of this tray are going to be, well, this distance here is the same as this distance here, okay, which is 50, but I've taken away x from both sides. Okay, so it really has dimensions of 50 minus 2x. You can do a similar thing on this side. This dimension is really over here, which is really 40, so the whole thing, take away 2x. Okay, and hopefully you can see when we fold these squares up, that height is actually x. Okay, experiment with a piece of paper yourself, see what happens. So this one I'm going to be able to write down directly. Okay, the volume is equal to the volume of this thing, even though it doesn't have a lid. Our normal formula, length times width times height. So 50 minus 2x, 40 minus 2x times x. Okay, and you should do the expansion, definitely do the expansion. Since we've got two brackets times x, I'll leave the x outside. So 200 minus 100x minus 80x plus 4x squared. Yeah, you do some collecting like terms in here. Maybe put it in the correct order as well. And now I can expand the x to all of these guys. Okay, that is the formula that you're going to have to optimize. Okay, in terms of the dimensions of the tray, to state your answer, so in the answer it just asks you for the maximum volume. If it asks you for the dimensions, you just have to remember that the length is 50 minus 2x, the width is 40 minus 2x, and the height is x. Okay, so once you optimize this, find the x value, you can sub it in to find the three dimensions that you're after.